Hello, good morning.
Good morning, ma'am.
How are you?
Fine, ma'am.
कौन बोल रहा है नाम बोलो.
Elia Shafkat.
Ilya. So let me see. Ilya, I am going to take your attendance and let me see. Ilya Shafkat. Ilya Shafkat, your name is not in my list, I think.
Elia खोखर होगा फिर.
आप रोल नंबर बोलो.
241
241
545517
5455
17.
17. Let's see. मिल गया. ठीक है.
किस नाम से मैम?
खोखर पहले है और फिर बाद में एलिया शफकत है.
Okay.
Okay, let's see who's next. So Aruba Riaz.
Yes, ma'am.
Hello beta.
Mm.
So this is your first class, Aruba? Aruba, I cannot hear you.
Yes, ma'am.
Okay, because you're an odd roll number. Anyway, so Halima Ijaz.
Yes, ma'am. Yes, ma'am.
Acha, Halima, let me try to find your name. Can you tell me your roll number?
241
241
547762.
547762. Okay, I found your name.
Yes, ma'am.
Okay, so this is your first class as well.
Ma'am, I've taken in-person classes.
You have taken class. Okay, that's great. Okay,
Yes, ma'am.
okay, then it's fine. Let's see. Mahnoor Amjad.
Yes, ma'am.
Hello, Mahnoor. So let me see your name in the list. Okay. Mahnoor, you have been coming to classes, right?
Yes, ma'am.
Okay. And then we have Nashra Rashid.
Yes, ma'am.
Okay, Nashra, let me see. You have also been coming, right?
Yes, ma'am.
Okay. Nimra Arif.
Yes, ma'am.
Nimra, you've also been coming?
Yes, ma'am.
Okay. And then we have Sahib Khan.
Present.
Good, Sahib.
Yes, ma'am.
Okay. And then we have Nawab Sadiq. Who is Nawab Sadiq? Nawab Sadiq, please switch on your mic. Okay. Okay, so let's start. I'm going to share my screen with you. Okay, so can you see my screen?
Yes, ma'am.
Good. Okay, so the topic we're going to study today is about errors and uncertainties, right? So you can see this here. This is your book, chapter number 1. And you can see this is figure 1.1, and you can also see the page, okay? You can see this is, yeah. Wait. Okay, wait. Page 13, right? Okay. So what do you understand by uncertainties, by errors? What are we talking about? Yes? Anyone would like to say something? Yes, please. I would like class participation. I will also give you marks for this, as I've already pointed out. So whenever I ask a question, I would like a response. So from your previous experience, knowledge, studies, whatever you've done, what do you understand by the terms uncertainty, errors? You are familiar with this. This is not the first time that you're looking at this, right? So can you say what you think it is? Any comments, any ideas? Bolo?
Human beings can always
Who's
make
speaking? अपना नाम भी बताया करो.
Aruba Riaz.
Aruba, yes.
Human beings can always make errors.
Please speak louder.
Humans cannot always make accurate measurements. हमेशा मतलब जैसे पैरेलक्स एरर हो जाता है या something like that.
Okay.
तो वो उसकी वजह से there can be uncertainties and we cannot always get accurate results.
Okay, that's right. So she's talking about the fact that whenever we do a measurement, it can be a simple measurement like measuring length or mass or anything. It can be something you do in the lab. It can be something you do outside the lab. There's always a margin of error. Okay, so there's always a uncertainty. And there can be different reasons for this. And since in while we are doing this scientifically, sometimes measurements are very sensitive and we have to take these factors into account. And we have to try to minimize the error or the uncertainty in the measurement. So we have to first understand why we have these errors, and then we have to understand how we can minimize it, and then we can understand how we calculate or quantify these errors, right? She also used the word accuracy. Accuracy is another topic relevant to this, and with accuracy also comes the term precision. So we'll be talking about these. Okay. So what kinds of errors can we have when we're measuring something? That's my question to all of you. Why do we have errors? What kind of errors? What can be the reason or the causes for the errors?
Ma'am, it is
Ma-
the least count. The errors like count up to the
नाम
least.
बताओ.
Laiba Khalid.
Okay, least count. Yes,
Yeah, least.
Laiba. So least count is another term that we come across this. How do you define the least count?
I'm not sure about it.
Okay, so were you in the lab last time, Laiba?
No, ma'am, I'm an odd one.
Right, okay, fine. Anyone
Ma'am,
else?
I need
Yes, ma'am,
something.
least count is the
Ek
minimum
minute.
value of the scale.
Naam batao.
Sahib.
Sahib, yes.
So least count is the minimum value on the scale of measurement.
Okay, yes. So it's also defined as the minimum measurement that can be performed on any instrument. That's also a definition of least count. Yes, Sahib. Can you give an example?
Yes, for example, on vernier caliper, we had 0.1 as our least count, 0.1 millimeter.
0.1 millimeter was the least count. How did you calculate this?
Well, we 0.05, I think that was the least count because uh, I just can't, I forgot it. I think
You don't,
0.05
okay,
was.
you don't remember it, but do you know how you calculated this value? How did you determine this value? There was a method of calculating this value. Did
Yes,
you?
we had a formula.
Yes.
So in which we had, well, I've written those in my notes.
Okay. Okay, right. So anyway, please don't take any of these values to be correct until you understand how it was calculated, and then you will know the correct least count of the instrument you used and whatever you will be doing in the future as well. But again, I come back to the meaning of least count, which is correct. It's the smallest measurement that can be made with any instrument, and this instrument can be a ruler, it can be a weighing scale, it can be any something like a vernier caliper, a screw gauge, whatever we are using. Okay, so let's go further. The reasons for the errors can be many, right? So one of the reasons can be human error, right? So whenever we are trying to measure something, we as humans can be the cause of error. There can be many different reasons for this, right? Sometimes we're not handling the instrument properly. Sometimes, whenever you're looking at a scale, we always tell you to look completely straight on the scale, not sideways. That also induces an error. That's an example. And then the environmental factors can also be an error. And then there are some errors that are systematic errors. These are due to the instrument. You know that whenever you have anything at home, let's say the weighing scale on which you check your body weight, right? Sometimes you know that the needle is a little bit behind the zero, and therefore when you stand on that scale, you know that when you will measure your weight, you will add the value that's, that the needle was lagging behind the zero. Sometimes it's behind the zero, sometimes it's in front of the zero. So therefore you have to add or subtract accordingly. And that's why one of the first things we do when we look at an instrument is to check the zero position. Is it right or wrong? If it's right, then you don't need to add or subtract anything. But if it's not, then you do have to take that into account when you're measuring. Okay. Okay. Now, we have talked about these terms and their meanings, and now we also have to see how we can, because we want our measurements to be reliable. The reliability of the measurements depends upon the fact that we do understand these errors and uncertainties, and we do minimize them. So let's go further. So one of the ways of doing this is that you find when you go to the lab, we ask you to take a number of readings. We don't ask you to take only one reading. And what's the reason for that?
Yes,
Reliability.
scanning better.
कौन बोल रहे हैं? Yes.
Sahib.
Yes, Sahib, what did you say?
So it is more reliable.
No, how reliable? When you take a larger number of readings, how does that become reliable?
I mean, we get the mean of
Yeah.
those separate.
You take
Yes.
a larger number of readings and then you take the average or the mean of the readings.
Ma'am,
Yes, your name?
Saurabh Fakat, ma'am, when we increase the reading, the margin of error will be decreased.
Yes, and that is done by taking the average or the mean of those readings,
Yes.
right? Okay, right. So these are some of these terms that we will be working with. And another term that we use, a common procedure that we use is also called the mean deviation. We either use the mean or we use the mean deviation. Okay, so these are some quantities that are used to understand these things. So there's a small problem here that we will solve together. So you can look at this problem. This is 5 students measured the mass of a rock, and their measurements were 18 grams, 22 grams, 19 grams, 18 grams, and this is also 19 grams. It's not 22, it's 19 grams. Okay, so what is the mean and what is the mean deviation? So how do you calculate the mean? The mean is calculated by, if you're not, listen, if you're not speaking, your mic should be off because it's causing a disturbance, okay? You only switch on your mic when you have to say something, okay? Yes, please. So how you take the mean by adding all the values that you are given by the total number of values, right? These are the total values and these are the values given. And then this is the mean. This is very simple. You know how to do it. The second way of doing this is the mean deviation. So who can explain how we found this mean deviation?
Ma'am, solve factor. Mean deviation, we can find x minus x bar divided by the mean value. In this way, from this formula, we can derive the mean deviation.
Okay, can you please explain how this works with this example?
Ma'am, I didn't understand what you said.
I said that can you explain how we got 1, for example, here? बेटा ये किसका mic on है? देखो आप सिर्फ वो माइक ऑन करें जो क्वेश्चन आंसर करता है, ओके? बाकी लोग ना करें, राइट? ओके, सो हु कैन एक्सप्लेन हाउ वी गॉट 1 हियर? ये 1 कैसे आता है?
मीन से माइनस करके।
ये कौन बोल रहा है? कौन बोल रहा है?
नवाब।
नवाब जी। नवाब, मीन से, मीन हमारा था 19 और उससे हमने क्या सब्ट्रैक्ट किया? 18. सो 19 minus 18, that's 1, okay? And the second one is 22 minus 19, that's 3, okay? Then 19 minus 19 is 0. 18 and 19, the difference is 1. You're not looking at the signs in this case, and this is 0. And then you divide it by 5 and you get 1. So is that clear now? How you get the mean deviation, right? And the mass now can be written as 19. The value was 19, which is the mean, and plus minus 1 gram, which is the mean deviation. So this is the final result. The plus minus gives you the uncertainty. Is that clear?
Yes, ma'am.
Okay, good. So now we can go and talk about errors. So we have absolute errors and we have relative errors, okay? So absolute error is equal to the limit of reading of the instrument or of the smallest graduation on the instrument scale. This is what we just called the least count, okay? So the least count is the absolute. And if you have the value of the absolute error, you can find the relative error by using this formula. Absolute error divided by the average measurement. And if you have this, you can also find the percentage error. Okay. So these are different formulas that we can use. Now here are some examples. Now this is a scale. You can imagine it's a weighing scale, maybe your kitchen scale. You know, in a kitchen also we use weighing scales, right? So there are different weighing scales we use. You can have your own scale for measuring your body weight, but it will be a different scale. And you will have a scale in the kitchen for measuring or weighing whatever ingredients you're using, okay? So what's the difference between the bathroom scale that you use for measuring your body weight and the scale that you have in the kitchen? Yes. Who will answer this?
मैम वो वॉशरूम वाले स्केल की रेंज ज्यादा होती है।
Yes, exactly, because you have to use the scale that is appropriate for the weight you're going to measure. If you cannot stand on the kitchen scale, you will destroy it, right? Because the maximum value you can read with your kitchen scale is much less than your body weight. So you have to find an appropriate scale according to the measurement you have to perform. So therefore, this is an example. In this case, the limit of measurement is how much? The limit of measurement is 0.1 kg. This
1
is
kg.
0.1 है. सबसे छोटा जो है वो 0.1 है. ये गलत लिखा हुआ है, right? So the limit of measurement in this case, or the least count, will be 0.1. And the maximum reading you can have is 2.5 or 2.4. At this time, the reading is around 2.4. Okay. And the uncertainty is equal to the smallest measurement you can have, which is 0.1 kg. Okay. Now let's look at a ruler, right? So measurement of length, something you use very normally you've been using throughout life, right? So the limit of measurement in this ruler is the smallest measurement you can measure is 1 millimeter. So now you understand why we use a vernier caliper in the lab. If you want to measure something that's less than 1 millimeter, then you have to go to a vernier caliper, because the limit of measurement in a vernier caliper is less than 1 millimeter. So again, you choose according to what you have to measure. If you want to measure something in kilometers, of course, you're not going to use something with a graduation of 1 millimeter. You don't need that, right? So you will choose accordingly. The uncertainty in this case is 1 graduation, and 1 graduation in this case is 1 millimeter. 1 millimeter, if you convert it to centimeters, will be equal to 0.1 millimeter. You know that 1 centimeter is equal to 10 millimeters. So you see this 1 is centimeter, and we have 10 divisions inside the centimeter. So these are in millimeters, and then the total is 1 centimeter. Okay. Now,
Yes, ma'am.
if for
Yes,
example,
ma'am.
yes, right. So if, for example, you have to measure the length of a block, let's say this is a wooden block, let us say, and you place it on your ruler, then you will find the initial value and the final value, and you will subtract these values here, and you will find the length of the block. But in addition to that, you will also write the plus minus uncertainty, which is the smallest measurement that can be made on this instrument, right? Now let's look at another example. Okay. So this example is about the formulas that we just used above. Okay. And in this case, you can see you are given two values. This is about a meter ruler, right? You are given a length of 2 meters with an uncertainty of 1 into 10 raised to minus 3 meters. 10 raised to minus 3 meter means what? This is equal to 1 over 1000. So this is equal to 0.001 meter. Okay.
Meter.
Yeah, that's the uncertainty. So the length 2, again, the measurement is this, and this is the uncertainty is the same because the ruler is the same. So when you want to find relative error using the formula that we had above, we divide the uncertainty by the measurement, and this is the value we have. And then for the second length, again, we use the same formula, and this is the value we get. Okay. And we see that the value of the error is different for different measurements. For example, the error for length 2 is larger than the error for length 1, because this is a minus value. So you see this is a smaller value and this is a bigger value. So the higher the value of the error, it means there's a bigger error, there's bigger uncertainty, which is not a good thing. We want it to be as small as possible. Okay. Now, length, we know, we talked last time about basic or fundamental quantities. So what were the basic or fundamental quantities? Like length is a basic quantity, right? And similarly, mass and time and so on. And then the all other quantities are derived quantities. Okay, for example, velocity is a derived quantity, force is a derived quantities. It means that these quantities depend upon these basic quantities. So if we gave an example of length and mass. So length and mass are basic quantities, and now we can also apply the same rules to derived quantities. So here you have a rule which has been highlighted.
Excuse me, ma'am.
Yes. नाम बताओ. बेटा नाम बताया तो.
Saul Rafaqat,
Yes, please.
ma'am, I just want मुझे ये uncertainty को हम error कह सकते हैं मैम?
जी कह सकते हैं.
बस यही कंफर्म कर.
Okay, ठीक है. So when two quantities are added or subtracted, the error or uncertainty, ये देख लो एक ही उसमें यूज हो रहा है. ठीक है. The error or uncertainty of the sum or difference is the sum of the separate errors. So अगर दो quantities हैं और आपने उनको add या subtract किया, the total error will then be a sum or the difference of the separate errors. Okay.
Yes, ma'am.
Okay, and now you have another example. You have a measurement X, which has these values plus this uncertainty, and you have a measurement Y, which has this value and this uncertainty. Always pay attention to the units, use the right units as we have talked about. So when you sum the quantities, you're going to sum the error. And when you subtract the quantities, you're going to subtract the error, okay? So that's how it is. So now here we have another example. We can work this and understand it. So the rule number 2, the first rule was for addition and subtraction. The second rule is for multiplication or division, right? So when quantities are multiplied or divided, the percentage error of the sum or quotient is the sum of the separate percentage errors. So percentage errors are always added, okay? So let us look at this example. A student determined the circumference of a coin to be 100 plus minus 1 millimeter and the diameter to be 32 plus minus 1 millimeter. Now use this to determine pi. So a coin is what? It's a circular shape, right? And it has a certain diameter, right? So this diameter value is given to be 32 plus minus 1 millimeter. What's the formula for the circumference? The circumference formula is who will answer this? Hanji, bolo. What is the circumference formula? Come on, guys. This is something you've done in school. What's the formula?
2 pi r, ma'am.
2 pi r. And if we want to write it in terms of the diameter, then it is pi into 2r. Diameter is 2r, so it's pi multiplied by the diameter d. ठीक हो गया? Okay, now
Yes.
what was the above formula for percentage error? You have to have the error divided by the measurement, 1 divided by 100 and multiply by 100, right? And you get 1%. So this was the formula we just studied above. And then in the diameter, this is for the circumference. For the diameter, again, we have the value. The value is 32, so we put it here. The uncertainty is 1, we put it here. We multiply it by 100 and we get 3%. So the value for pi will be what? It will be, so circumference was equal to pi d. So pi is equal to circumference divided by what? D. Okay, so circumference was 100 and d is 32 and this is your value. But remember that this is not a question of basic circumference. The question is more about uncertainty. Okay, so you have to give the uncertainty in pi. The uncertainty in pi, as we just said, when quantities are multiplied or divided, the percentage errors will be added. So the percentage error in 100 was 1%. The percentage error in 32 was 3%. We add the two and the percentage error now is 4%. So therefore, the value of pi that we've calculated, 3.13, will be plus minus an uncertainty of 4%. Okay? Is that clear now?
Yes, ma'am.
Good.
Yes, ma'am.
Yes, ma'am.
And then if you are asked, what does 4% mean? You can calculate 4% of this. How will you calculate this? 4 over 100 multiply by 3.13 and you get the answer is equal to 0.13. So therefore, if you want to write it in terms of percentage, this will be the answer. And if you have to write it in numbers, this will be the answer. Okay. So please practice these problems and concepts at home, okay? And as I said in my previous classes as well, you can also see these recordings. They're available for you. Like I've already given you these links in Moodle. So you will see that if after every class you spend, let's say, 1 hour in the evening practicing the concepts and the problems that we've done, you will perform well in the course and you will not have any stress. Okay, there will be no stress or burden and you will go very smoothly if you, after the class, you find at least 1 hour in the evening to do the same thing, to practice it and do it yourself. Like, for example, you take this problem, first you study what we've studied, you clarify your concepts, and then you write this problem in a notebook, close your book and try to solve it yourself. Okay, if it's wrong, then it means that you,
Yes, ma'am.
if it's wrong, it means you made a mistake, you misunderstood some concept or some formula, then you go back and study it again, and then you close the book again and solve it again yourself. If you do this, this will be the perfect preparation for doing well in the course, for performing well in the quizzes, assignments, and so on. So the course is not difficult, it's very basic, but you need practice. Okay, you cannot memorize this. This is not based on memorization. It's based on understanding and practice. Okay, so we first understand the concepts and the formulas, and then we apply them to solve these problems. So the way to do it is just to spend 1 hour every evening doing this, and then all your assignments, quizzes will go fine, your exams will be fine, and you don't need to worry or stress. You cannot stay awake one night and cram everything, because if you try to cram it, you will mix it up. Okay, so it's a very easy course, as long as after every class, which means 3 days a week, you give at least 1 hour in the evening to sit down and practice what we have done. And the important thing is, don't wait till you have the quiz or the assignment or whatever. You have to do it regularly, because if you gather all the work to do after, let's say, 1 week or so, then again it will be difficult for you. Okay, so don't try to.
Ma'am,
Hanji.
Laiba, this is Laiba. Ma'am, I need to ask, जो आपने week 1 में there's something to submit. Do we have to submit that?
Laiba, you sent me an email also, and I told you no, there is nothing to submit in week 1. So it was okay. So आप दोबारा
No, ma'am, that was
Yes, I know.
Okay.
I understand it. I've corrected those settings in Moodle. Check it again. Are you still seeing it like that?
Yeah, ma'am. And the email was about the WhatsApp group, and this one submission.
I
Abhi
have not yet formed the WhatsApp group. Okay, so when I form
Okay,
it,
ma'am.
I will let you know. So there was,
Thank you, ma'am.
yeah. Okay, another thing I would like to tell you. This meeting is going to end in a few minutes. So is there someone whose attendance I've not taken?
Me, ma'am. Sound Fakar.
1 minute. Let's see, Rafaqat. How do you spell RAFA?
QAT.
ठीक है रफाकत, हो गई आपकी.
Thank you, ma'am.
So let's see. We should have 10 people right now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. ठीक है. Okay. So you
Excuse me, ma'am.
हाँ जी.
मैम इसके नोट्स हमें उस पे मोडल पे मिल सकते हैं, आप अपलोड कर देंगे?
You don't need notes. You're getting the text, you're getting the explanations in the recordings, ठीक है? And the next thing you have to do is the practice. Okay.
Okay, ma'am.
ठीक है. I'm not asking you to memorize anything. I've not designed this course based on memorization, right? Okay. So also, you remember that I've given you deadlines for your assessments. You remember those? आपको याद?
Yes, ma'am.
Yes, miss.
Yes. So what were those?
Ma'am, I don't know. Please, can you remind us?
Who's this speaking?
Saul Rafaqat, ma'am. This is my first class.
Okay, Saud Rafaqat, please go
Yes.
to Moodle. You will get the link for the previous class recordings, and in those you can see the dates. Okay.
Okay.
We wrote them on the board. Okay, and check the last class recording. ठीक है?
Okay, ma'am.
So those were the dates that we had. And now we can go further. We talked about graphical analysis in the last class, and you can again practice that. We talked about graphs and trend lines and the slope and so on. So since this is your first class, you should go through the recordings that we have and through the chapter that we have. done and practice it. And if you don't understand anything, then you can ask. Is that clear? ठीक है?
Yes, ma'am.
Good.
Yes,
So,
ma'am.
for example, we can take a look at the topic that we studied in the beginning of this class. You see there's this table here. So let's fill this table. You can look at this. So again, I can put this question to you and you can answer it to me. So density will be kilogram per meter cube. So who will tell me for velocity? This is based on the system of units that we did in the beginning, right? Last week. So what will be the units of velocity?
Meter per second.
So the unit will be meter. Who is this answering?
Nawab Siddiq.
Nawab Sadiq. Nawab Sadiq, this is your first class? No, you were in the class last time as well. ठीक है ना?
Yes, ma'am.
Good. Okay, so acceleration, who will answer for acceleration? Acceleration, you can write it in words over here, right? Okay, so acceleration is, the units for acceleration are?
Ma'am, meters per second cubed.
Meters per second cube. Who is this answering?
Aruba.
Hmm?
Aruba.
Aruba. She's saying meter per second cube. Is she correct, Aruba?
Ma'am, it's meter per second square.
Who is
Where?
speaking?
Mahnoor.
Mahnoor. Can you tell me why there was a mistake? How do you know that it's squared and not cube? Yes? You can use the formula. Acceleration is equal to velocity divided by time, right? The change in, or you can say it's the, okay, acceleration is equal to change in velocity divided by change in time. So this is velocity unit is meter per second divided by second. So this means meter per second squared. Oh my God, why did I do this? Here. So meter per second, so this is not cube, it is squared. Okay, so that's the correct answer. So let's look at the next one, which is volume. What will be the unit for volume? The unit for volume.
Cubic centimeter.
Who is this?
Laiba.
Laiba. Cubic centimeter. Will anyone else say if this is correct or this is wrong? Is this correct or is this wrong?
Ma'am, I think it's.
Ma'am, I guess it's meter cube.
And why? Who is speaking now?
Ma'am, Mahnoor.
Mahnoor, why do you think it's meter cube? Because we are talking about SI units.
The units.
Okay. So now the meeting is going to end. Okay. Anytime. We have a few seconds. So you can complete this table yourself at home. Okay. When you study in the evening. Right?
Yes, ma'am.
So please go to Moodle and check the links that I have uploaded, and so that you can practice and catch up if you've not done it before last week. Okay, so do it so that you can then give good assessments and perform well in the course. Is that okay?
Yes, ma'am.
Okay, thank you.
God bless you, ma'am.